Alright, this is my second video on graphing polynomials. So I have another function here, f of x equals 1/6 times x plus 3 squared times x minus 4. So the first thing we're going to do is we're going to start off with zeros, and zeros come from your factors. So for example, if you have x minus 4 there, you take x minus 4, set that equal to 0 and solve. So you get positive 4 from that. The new piece in this video is we have this x plus 3 squared. Remember, that's the same as like x plus 3 times x plus 3. So if you had just a plain old x plus 3, you're going to get a 0 of negative 3. And then if you have another x plus 3, you get another negative 3 as a 0 as well. Another way you can look at that is, see how we have x plus 3 squared? Well, you can just look at the parentheses only, and we should be able to look at these and tell, all right, the 0 is negative 3. But since it's squared, I'm going to have 2 of them. So if it was to the third power, I'd have 3 of them. If it was to the fourth power, I'd have 4 of them. So we have zeros of negative 3, and 4. So from there, there's a connection between zeros and x-intercepts. Our zeros are our x-intercepts. So I'm going to have at negative 3, 2 dots there, 1 at positive 4. So my x-intercepts are the coordinates, which is going to be negative 3, 0 for this one. I have negative 3, 0 again. And then at positive 4, we'll call that 4, 0. So I have 3 x-intercepts there. Next, we can find the y-intercept to help us get our graph going here. To find a y-intercept, if you notice for x-intercepts, the y values are all 0. To find a y-intercept, the x value is 0. So what we're going to do is we're going to plug in a 0 for all of our x's up here and then just simplify that. Easiest way to do that so you don't make silly mistakes is just put it all in your calculator. So I already have it pre-put in. I have 1/6 times 0 plus 3 squared times 0 minus 4 in parentheses. So if you notice, this looks exactly like that, just the only difference is my x's are zeros. So if I hit enter there, I get negative 6. So my y-intercept is going to be at 0, negative 6. So I could go on my graph, 0, negative 6, right there. Third thing, we can figure out what is the general shape, which tells us the end behavior. So I have 3 zeros here. If I have 3 zeros, that means the degree is 3, which means if this was in standard form, the highest power would be x to the third power. Now what we need to remember is you look at the degree to tell even or odd. So if it's odd, we're going to have an S. If it's even, we're going to have a U. So I know I'm going to have an S. Now I just have to figure out, is it an S going up or an S coming down? And that is all based on your A. So think back to transformations. This leading number is positive, which means, hey, we're not going to reflect this over x-axis, just leave it as is. So we're going to have an S shape going up, meaning we're going to start at the bottom left and we're going to end at the top right for our end behavior. So what we're going to do is we're going to graph this, but we would like to get pretty precise. So what we can do is you could go to your calculator and go to y equals and enter this entire function. So 1/6 x plus 3 squared, and I have the x minus 4 on the end. We could graph that, and this is what our graph looks like. Now, things to notice here is, I'll get to that in a second. What we're going to find next is let's find the maximums or minimums. So just like in my Graphing Polynomials 1 video, when you think of maximum, you think of a high point. So we're going to find local maximums and local minimums. So a high point would be here. So that's going to be a maximum, where if I keep following this graph, here's a low point. So that's a minimum. So you're looking for these peaks. These peaks are going to be your maximums and minimums. So I'm going to go through that same process of finding those maximums and minimums on our calculator. So the way we can do that, I'm going to start with the maximum, this left one. So we can go to second, calculate, which is this button right here, and we're going to go to the maximum option. If we want a maximum, make sure you're using maximum. It's going to ask you 3 questions. It's going to ask you for a left bound, a right bound, and a guess. So I notice I moved my little crosshair right where I think the maximum is. If I want a left bound, I'm going to move it a little bit to the left, so that's good enough. Hit enter. And it asks for the right bound, so I want to go a little bit right of where I think the maximum is. Hit enter. And then it's going to ask you to guess where is the maximum, which is right around there, and enter. So it's going to spit out and tell me what it thinks the local maximum is. So let me write this out. So we're going to have a maximum, and I have negative 3.000001. So if you round that, that's just negative 3. And then our y value, we have something interesting here. We have negative 1.4 e to the negative 12. What this is that's scientific notation when you have that e like that. So that's like negative 1.4 times 10 to the negative 12. So that's 0.000000000 11 times, and then 1.4. So that just rounds to 0. So our max is at negative 3, 0. And now, even though it's kind of covered up there, I'm going to find that minimum. So I'm going to go to second, calculate again. Go to option 3 for minimum this time. I'm going to move my crosshair down towards where I think it is, which is right in this area down here. Ask for a left bound, so I'm going to go a little bit to the left. Ask for a right bound, so we're going to go a little bit to the right. And then it wants me to guess where it's at, so I put it on the point that works. And we get those coordinates. So the minimum is going to be 1.6666, so we'll call that 1.67, and then negative 0.847. So we could plot these on our graph. So looking at it, max at negative 3, 0, that's again just this point here. Minimum 1.67, negative 8.5. So go over maybe 1.5, down 8.5. So there's 6, 7, 8.5. Now what we're going to do is we're going to play an interesting game of connect the dots. So I have to start at the bottom left and end up in the top right. But there's something interesting that goes on here. What's going to happen, so I'm going to kind of look at my graph here as a reference. So my graph on the calculator needs to mimic here is when I start going up to this first point at negative 3, you'll notice we do not go through. Well, what happens there is we have something called multiplicity. So whenever you have a 0 show up multiple times, you have multiplicity. If it shows up an even amount of times, so even multiplicity, what's going to happen is your graph will bounce off that point. Where if you have a 0 show up multiple times and it shows up an odd amount of times, so what I mean by that is I have negative 3, that's twice, so that's even, so we're going to bounce. If it was odd, like negative 3, that's 3 times, we'd go through. So what we're going to do is we're going to bounce off at that point. So you go up, bounce off of it, come down through the y-intercept, go to our local minimum, come back up, we're going to go through that point and end up. So my graph on my calculator resembles the graph on paper, so we are good to go. And that is graphing polynomials 2.